Hi, I'm Dr. Chris Chan from King's College London from the Geography Department. And this is going to be a quick video to show you how you can use ECOCROP in DIVA-GIS to predict species distribution modelling in under different climate scenarios. So really what we're trying to do is end up with something like this, where we have kind of the suitability of the environment, of the climate, for a particular species of particularly plant or crop. So in our example here we've used potato, and so you can see as I hover over, if you look down at the bottom, you'll see that there's kind of varying levels of suitability. So you see the reds are excellent, but if we hover over, then down on, if you look over here, you'll see that there's kind of 94, 95, so getting up to 100s over here for suitability. Over here, slightly less so, like 8% suitability. Obviously, the C is completely unsuitable. So yeah, effectively, what we're trying to aim to get out is exactly this, like a raster layer which has differing suitabilities classified right the way from 0% to 100%. So a quick kind of explanation of how ECOCROP works. It really works on the basis of there are certain conditions, both temperature and precipitation orientated, in which certain species kind of have an optimum where they thrive under, so they'll grow at their fastest rate. They kind of have marginal conditions which they're not really ideally suitable, but they can survive within these. And then there are kind of outside of those ranges, there are basically conditions where the species can't survive whatsoever. So on the left here, we've got a 2D model. On the right, we've got a 3D model of basically the suitability. And so depending on the temperature, we have certain kind of mechanistic known temperatures at which they're the optimum for a species. They're the kind of minimum and maximum for the species, and then basically outside of that we assume that the species would die. And similarly for precipitation, there's kind of a range where it's the optimum. So in this range, there's kind of the from the maximum to the minimum range here. Then outside of that, it's either too wet or too dry, so the species dies. So effectively, ECOCROP makes use of our understanding of these different species. So you can have a look in the database here. So this is all derived from the Food and Agricultural Organization's ECOCROP database. So if we select a particular crop, then have a look, then we'll be able to see, so this species needs at least 100 days for it to grow. It has a kill temperature of 0. Its minimum temperature is 5 degrees. Optimum minimum is 20 degrees. Optimum maximum 26 degrees. Absolute maximum 30 degrees, and then beyond that it dies. So similarly for the precipitation, there's kind of the optimum, the minimum, and the maximum. And so based upon all of this data, and yeah, because we happen to know effectively this is trying to predict over the course of a year, because it does it by month, is there a long enough time period for the crop to grow, and kind of just how suitable is it? And obviously, like, the temperature and precipitation isn't just kind of static, it varies with geography, so hence why we can use it to predict how well the species will grow under different climate scenarios. So here I've done it on just one scenario, but obviously you can run this on as many scenarios as you want. You can even run it with different species and then comparing, say, potato and a particular fungus, to try and determine, well, how much is a particular crop going to be affected by a parasite, fungus, whatever have you, in future under different climate scenarios. So how does all of this work? Well, to actually set up the climate model for ECOCROP in DIVA-GIS, DIVA-GIS, by the way, is a free and open source software, so it's basically freely downloadable. If you just do a quick Google of DIVA-GIS, then basically this DIVA-GIS, diva-gis.org, you'll be able to download it from there and install it. But yeah, once you've got the climate model set up, it's very, very easy to run a particular scenario. However, actually creating the climate scenarios for this is actually quite difficult. And because of that, I have made an R package called prepCLMdata, so prepCLMdata, where it does all of the kind of the nuts and bolts for you. So if you head to this GitHub, github.com/Dr. Chris Chan /prepCLMdata, for your screens, this is the link. But if you head there, there's an explanation of a step-by-step of how you go about installing this and using it. So if we go over to our studio, so for those of you who are familiar with R, it's a statistics program, again, free and open source. R Studio is basically a add-on to it to allow you to kind of easier manage your R environment. So I've copied the instructions from this GitHub, these step-by-step instructions here. So if you haven't already installed the DevTools package, then please do, just by having install.packages DevTools. So once it's installed, you then call the DevTools library, which you need to install my package. At the moment, I've had to do a quick edit on GitHub alone. So we'll install underscore GitHub and then the package. And because of that edit, at the moment we need false equals true. So that should automatically download the package from GitHub. You'll see it's asking you to update dependent packages. So yes, we can update all. Then once it's done updating those packages, just give it a second. Okay, well, our CCP shouldn't be necessary for the moment, so it doesn't matter that error's shown up. So next, let's call the library. So by the way, I'm pressing Control and Enter to run the particular code. So we'll now see under packages that our prepCLMdata. Is it prepCLMdata? So that package is installed and active now. So next, what you want to do, and here I've got set working directory, and then I've kind of given a misnomer here. Obviously, you would set it to wherever you want your data. For me, I'm going to, let's just make sure I have actually created that folder. And, yep, so I have this blank test folder. So we're going to set the working directory there. And then there's the step-by-step. The first thing you might want to do is to just run through it with example data. You can use the data from either WorldClim or Chelsea accurates. So if we try it with kind of prep example without any options, at the moment, and I've kind of recently updated this package because the WorldClim data is very kind of hit or miss whether or not it works. So what we can instead do is, if it's not working from world climb, if you put in the option 2, 1 is world climb, 2 is Chelsea-Cruz. So prep example with a 2 as the option, hit enter. Then what this will do is this will automatically download all the Chelsea-Cruz data from 2016. So it's kind of the latest available data based on observations globally around the world. Now, it can take a bit of time for this to download. It downloads one file for the minimum temperature for each month, one file for the maximum temperature for each month, and then one file for the precipitation each month. Now, again, here I'm just using an example that I've kind of set within the R package itself. I'll talk a bit later about how you can use this within your own data. Basically, it's running through the rest of the steps, but without this initial preparing the example data. So you'll see that we are on month 5. I'll quickly just pause the video and resume it again once we are done. Okay, so we have now downloaded the Chelsea-Cruz data, and you'll see that the working directory is changed to this test example folder. So let's have a look. So you'll see that all of our data is here. Once the thumbnail loads, you'll see that this is basically all precipitation data for each month of the year. Global, likewise temperature minimum, temperature maximum. So you can kind of see briefly a kind of raster image here. Right. So the next step is it's normally a good idea to just do a quick check to make sure that the package can understand your data. So to do that, just type check files and run the commands, and you'll see so it's found 12 precipitation files, so one for each month within our amended working folder. And so because there are 12, it's assuming that there's individual bands or individual files for each month. Similarly for Tmin and Tmax. The reason why it does this test is because sometimes you can have a raster layer where it's stacked. So it's got 12 different bands, so one for each month of the year, and they're all under one. So yeah, this is just to make sure that within your file system, it has that correct kind of number of files that it expects. It's really important that when it changes the working directory, that within that working directory there's only the files that you want to run for that particular model. Okay, so we checked our files, it's worked out that they're all fine. So the next step is to prep our climate data. Now you can run it like this if you want global coverage. However, I have now added options to have basically an extent of it. So this is particularly important for Chelsea-Cruz because it's quite high resolution data. So rather than running it across the entire globe, where it takes up about 3.6 gigs of memory, we want much less. So we're going to select a small kind of 2 degree by 2 degree area around the UK. Just to note, so it starts off with longitude minimum, longitude maximum, latitude minimum, latitude maximum. So the maximum extent, if you're looking globally, it would be minus 180 to 180 degrees longitude, and minus 90 degrees to 90 degrees latitude. But here again, we're just going to do it around the UK. So if we start running that, then you'll see that it starts resolving each of those bands. So we're going from this data where we've just got kind of our individual precipitation and temperature data for each month to these grids for the temperature minimum, temperature maximum, precipitation, but also a kind of, it's really important, and one of the reasons why I developed this package is to create an altitudinal grid, which basically determines where the ECOCROP model is going to run. So that's all done now. So files successfully prepared, directory for reference, and it's there. So it's normally a good idea to just take note of this particular location where it's output the data. So that's our first step. So we're done now in our studio, at least for our example data. So next step is go across to DIVA-GIS. Let's start a new project. So first thing we have to do is prepare our climate data. So come up to data, and then climate, and then make prepCLMdata. So now navigate to that folder which our studio just explained where it was. So D test example, and then another example folder, and you'll see it's automatically recognized all of these grid files. So with the suffix, just make sure that's empty, and then click files, and then it will load them all down here. So you might not have had any file selected down here, but once you kind of navigate to the folder and then click this files button, you'll see that it populates all of those files to prepare for the climate file. So next thing to do is click OK, and the process went super quickly here. Yours might take a bit longer. But you see it now says ready, so we can close this, and then we are ready to run our ECOCROP model. So to do that, come up here and select ECOCROP. Under the selection tab, you can change this to if you want to kind of manually look through for whatever particular crop you're looking for, or you can change it up here to a search. So let's look for apples. Ooh, apple. Which one? Let's just go for crab apple, I guess. So once you've single clicked it here, come across to the tab and select predict, or actually if you want to just check on the parameters tab. So you can see here's our species. It needs 255 days for it to grow. The temperatures and the precipitation parameters where it's kind of grows well. So yeah, you can have a quick check of that. Later on I'll explain how you can kind of add your own species in here. But next step, so on the predict tab, just make sure your climate database is selected. It's normally a good idea to select maximum extent, or if you had kind of a smaller extent, then feel free to kind of edit it here. So then set a suitable output. So we're going to call it apples, and apply. And you'll see that it's worked out that apples or crab apples can only really grow apparently to the far west of the British Isle, basically. So let's do that again with another crop. Let's try another type of apple. Predict. Then we'll call it apples 2. Apply. Okay, there you go. So, yep, say when you hover over, if you look down here, as I'm hovering over, you'll see that there's kind of differing suitabilities. Why is it? Oh, sorry, make sure apples 2 is selected. Okay, so yeah, you'll see that there's differing suitabilities as I hover over this. So the red areas are more suitable, or the grey areas are just completely unsuitable. So that in a nutshell is how you can prepare existing data for ECOCROP. Now, the obvious questions are what happens, or where can I find other climate data? So you can find other climate data from WorldClim, so worldclim.org, although at the moment, say, this doesn't seem to be working at the moment. So this does supposedly have historical and future high resolution data, but as I say, at the moment it doesn't seem like the links are working. You can download both paleo data, so historical data, and future climate data from Chelsea Climate, Chelsea, not Chelsea, and you can also download it from Climond. So if you were to use any of this data, then the way you'd use it is you would download whatever data you need. So let's have a look at a future scenario. So 2040, use UK's model and the socioeconomic pathway 1. So yeah, you would need to download the precipitation data, so PR, and you would need to download it for the different months that you would need. So just make sure you're only downloading kind of one scenario. So here you'll see PR01 right the way to PR12. So that's the precipitation for this particular model scenario 1. So you need to download that, the T maximum and T minimum, temperature maximum, temperature minimum, again for each month of the year, and just place them into a file themselves. So then basically what you're doing is you're just bypassing that prep example data. And say if you put that data in your drive over here, which were your folder over here, which was Chelsea SSP 126, which was our model, then you would set the working directory there, check the files, and prep the CLM data, and that's all you need to do. So that's how you use it with your own climate data or any other climate data that you can find. What happens if you want to add your own particular species? So the easiest way of doing this really is to close DIVA-GIS. If you navigate to where DIVA-GIS is installed on your computer, which for me, it's under Program Files and then DIVA-GIS, then there's a folder there called bin. And you'll see there's the ECOCROP database over here. You will need Microsoft Access for this. You also likely won't be able to edit it there. So the easiest way I find to do it is to copy it somewhere else. Start editing it in Access, so double click it. You can new record. So you can basically just create your own record here with all of the different parameters that you need over here. So the growing season, or the temperature data, or the precipitation data. So if we just give an example there, and let's close that, copy that ECOCROP example back, and let's paste it here. Paste. Then the next time you open DIVA-GIS and you go to run your ECOCROP model, you should be able to find that species which you've just added. So here, you can see I've found that species, albeit it doesn't have any data, so it's not showing up here. So that's how you would go about adding your own species. Now, when you have some of your data already, so grid files are quite difficult to use in other GIS systems. Like, not a lot of them readily recognize them. So what you can do, rather than messing around with these grid files, is in DIVA-GIS, once you've run your particular model, you can come up to Data, Export Grid Files, and then Single File. And then Esri ASCII is normally kind of a particularly good one to use. So potato exports, just prove that it has been done. So once that's done, let's just open QGIS and navigate to our potatoes export. So if we import this into QGIS, then you'll see we have our suitability from 0 right the way up to 100. So what we can even do is come down to transparency and add 0 as a no data value. So yeah, you'll see here, yeah, we have our suitability map now over the entirety of the UK. And again, this is kind of just highlight as well that though DIVA-GIS separates out the symbology into these different classes, in reality it's not classified in that way. In reality it's a continuous variable from 0 to 100, so it's percentage suitability. So that is all you need to model species distribution, at least mechanistically, so when you have some understanding about the species itself. Once again, I am Dr. Chris Chan from the Geography Department of King's College London. Yeah, feel very free to use this package. If you have any questions, then please don't hesitate to get in touch. My contact details are at the bottom here. So yeah, if you get in touch either by submitting an issue or getting in touch, then I'm very happy to help you out with this. Thank you.